everyone, it's Goodell speaking. We are going to be going over our practice test today, so make sure you either have your practice test out in front of you or you grab a blank practice test off of our classroom brochure holder. When we are going over this test, you need to make sure you are writing down all of the work that I put on here if you did not originally complete that problem. If you did originally complete the problem, you should be correcting any mistakes you make and writing down the correct solution next to it. I would also highly recommend that any problems that you were not able to correctly solve or you did not know how to attempt, you add to your one-pager. Please make sure over the weekend you have your one-pager complete and ready to turn in. On Monday we are taking that test and you need your practice test and one-pager finished at the start of class. So to begin, we need to make sure we are following our order of operations for all of learning target 1 in order to simplify these expressions. So remember, for order of operations, we start at parentheses and work our way down. So, looking at my problem here, the first thing I need to do based on my PEMDAS is simplify the inside of my parentheses, or my absolute value. So, 3 minus 4 is a negative 1, so the inside of my absolute value now will become a negative 1. Nothing else about the problem has changed, so I just drop down the negative 3 and my plus sign. Now that the inside of my parentheses have been simplified, I can actually apply the absolute value. Remember, our rule with absolute value is anything you take the absolute value of will become positive. So I have negative 3 plus a positive 1 after I take the absolute value. Negative 3 plus 1, these two numbers have different signs, which means I subtract them and take the sign of my bigger number. So negative 3 plus 1 will give me a negative 2 for my answer here. We're going to do the same order of operations on every single problem on the front side. So please make sure you know your PEMDAS or you are looking up front in the classroom to write that down somewhere. For problem 2, we have the absolute value of 2 plus 5 minus the absolute value of 10 minus 15 plus the absolute value of 3. So just like last time, we are going to begin by simplifying the inside of my parentheses. So I'm going to rewrite this down, leaving the inside of my absolute values blank. 2 plus 5 is 7. 10 minus 5 is a negative 5. And now that I have simplified the inside of my parentheses, I can apply the absolute value. The absolute value of positive 7 is just positive 7. It remains the same because it's already a positive number. Then we subtract, and then we are taking the absolute value of a positive 5, or of a negative 5, which is going to turn into a positive 5. So now we have 7 minus 5, and we have not changed plus 3, so that just drops down without changing. For addition and subtraction, we need to just go left to right. So we do 7 minus 5 first. That is going to give you a 2. We are left with 2 plus 3, which hopefully we can all do, to get an answer of 5. So that is how you simplify the expression for problem number 2. If I am going too quick while explaining this, please just rewind the video and rewatch the explanation to give yourself a chance to write down or listen to anything that you may have missed. On problem number 3, we have negative 2 times the absolute value of 1 minus 4 minus the absolute value of 1 plus 2 minus 5. So again, we need to begin by simplifying our absolute values here. So when I do this, I'm going to rewrite everything outside of my absolute value bars. Inside my absolute value bars here, I have 1 minus 4, which is going to give me a negative 3. And here, I have 1 plus 2, which is 3, minus 5 is going to give me a negative 2 inside my absolute value bar. Please remember, for addition and subtraction, we always go left to right. So now that I have simplified the inside of my parentheses, I can actually apply the absolute value again. So now I have negative 2 times a positive 3 after I take the absolute value of negative 3, and then minus the absolute value of a negative 2 is a positive 2. So next, we have to do multiplication before we can subtract. So negative 2 outside of the parentheses here is going to multiply the 3 inside of the parentheses. Negative 2 times 3 is a negative 6. We now have negative 6 minus 2. When we subtract from a negative number, we get a bigger negative. So negative 6 minus 2 is going to give you negative 8. And for our final problem on the front side, we have 6 minus 2 times the absolute value of 2 minus 4 minus 3 times the absolute value of 1 minus 4. So on here, again, it is extra important we follow those order of operations. I'm going to rewrite PEMDAS just so we keep it in mind when we go through here. Right. So again, first step is always simplify the inside of my parentheses. So I'm going to rewrite the problem with the absolute value bars kept in there. So 6 minus 2. Leave that blank for now. Minus 3, absolute value. So inside my first absolute value bars, I am doing 2 minus 4. 2 minus 4 is a negative 2. On the other side, we have 1 minus 4, which gives us a negative 3. Now that we've simplified the inside of our parentheses, we apply our absolute value. So I have 6 minus 2. The absolute value of negative 2 is positive 2. Because again, the absolute value of any number is a positive. Minus 3 times the absolute value of negative 3 is positive 3. And again, before we are able to move on to our addition or subtraction, we need to make sure we are multiplying our terms here. So 2 next to this 2 inside of parentheses is multiplying, because again, there is no number in between. There is no operation in between them other than parentheses, which always means multiplication. So a negative 2 times a positive 2 is going to give us a negative 4. We do the same thing with negative 3 and positive 3 here. A negative 3 times a positive 3 is a negative 9. And then lastly, we have to remember to drop down our 6 because we have not changed that at all yet. So now we have 6 minus 4 minus 9. So for addition and subtraction, again, we go left to right. So first we would do 6 minus 4 is going to give you 2. 2 minus 9 is going to give you an answer of negative 7. Again, if you missed any part of my explanation when working through these first 4 problems for learning target 1, please just pause the video, go back, re-listen to the part you were confused by, and make a note about whatever confused you in your one-pager. Right, I'm going to move on to the back side now. So for the back side, we are now solving equations featuring absolute value bars. So when we do this, please remember we are undoing when we are trying to isolate a variable. So we are not following our order of operations. We are doing SADMAP. We are reversing our order of operations. So since I have an isolated since I have isolated absolute value here, there is nothing on the outside of these absolute value bars on my left side of the equal sign, which means I can get rid of my absolute value bars. The way absolute value works is it makes anything inside positive. So we don't know if the inside was originally positive or negative, which means when we get rid of the absolute value bars, we have to set it equal to the positive version of the other side. So x plus 5 equals positive 3. But we also have to set it equal to the negative version. X plus 5 equals negative 3. However, for both of these problems, you are going to solve them with the same step. For problem 1, for our positive version of the problem, we are going to isolate x by subtracting 5, which gives us a final answer of x equals 3 minus 5 is negative 2. On the side with our negative value, we are going to do the exact same step. We'll just get a different answer. So to get rid of the plus 5, I'm still just subtracting 5 on both sides, which leaves me with x equals negative 3 minus 5 gives me a negative 8. So my two answers for x are x equals negative 2 and x equals negative 8. So for these absolute value problems, you should be getting two answers from them. right? For problem 6, it is very similar. There is nothing outside of my absolute value bars, so I can go directly into dropping them. So just like before, when I drop my absolute value bars, I will set one version of the inside equal to a positive value, so negative 2x equals positive 24, and I will split it, so I also set negative 2x equal to a negative value, negative 24. However, both of these still just have that same one step needed to solve the problem. On both of these, you just need to divide by negative 2 to isolate your x, but you are going to get slightly different answers for both. Positive 24 divided by negative 2 is a negative 12, so you get x equals negative 12. On the other side, a negative 24 divided by negative 22 is going to give you a positive 12 because two negatives make a positive. If you're having trouble with that, please write your triangle. Remember, we cover up what we have. Whatever we don't cover up is what our answer will be. All right. For problems 7 and 8, before I can drop those absolute value bars, I first need to isolate my absolute value on one side of my equation. So I can see on the left side here, I have a negative 2 outside of those absolute value bars. So before I can get rid of the absolute value bars, I need to get rid of the negative 2. This negative 2 is currently trying to multiply the inside of here. So to get rid of it, I have to use the opposite operation, which is division. So I'm going to divide both sides by negative 2, which will cancel out here, leaving me with just the absolute value of 3x plus 5 over 2. And on the other side, negative 6 divided by negative 2 is going to be a positive 3. All right. So now my absolute value bars are all by themselves, so I can move on to getting rid of my absolute value bars and then work on isolating the variable. So I get rid of my absolute value bars again, just like always, by splitting this into two problems. My first problem is the positive version. 3x plus 5 over 2 is equal to a positive 3. My second equation is going to be the negative version. 3x plus 5 over 2 equals negative 3. But again, both of these are going to have the same steps we need to isolate for x. The only difference should be what answer you get. So on the left side, I'm going to start by multiplying by 2. That's because the bottom of a fraction is always doing division. So to get rid of the bottom of that fraction, I have to undo it with multiplication. So multiply by 2 on both sides. I do that for both versions of the equation. So on my left equation with my positive value, that gives me 3x plus 5 equals 6. And on the right side, that's going to give me 3x plus 5 equals negative 6, because negative 3 times 2 gives you a negative 6. Now it is just a two-step equation. So we always undo addition or subtraction first in a two-step equation. 6 minus 5 is 1. So this problem leaves me with 3x equal to 1 at the end. And on the negative version, we do the same step. Minus 5 on both sides. That cancels out. Negative 6 and negative 5 combine together to make negative 11. Because remember, if we subtract from a negative, we get a bigger negative. So 3x equals negative 11. So your final step for both of these is to divide. Divide by 3 on both sides. Here, you get x equals 1 over 3. And on the other side, when we divide by 3, that gives us x equals negative 11 over 3. All right. I know previously when we were working on problems that ended in a fraction or a decimal, students were worried they may have been incorrect. Please note, these are both the correct solutions here. You should be getting fractions on some of these problems when you solve them. That does not mean you are doing them incorrectly. Like, against a lot of fractions in the real world, so you need to be comfortable working with them. Double check your answer if you get one and it seems like it might be wrong. But after checking your work, it's still there. Don't change your answer just because it's a fraction. You're likely correct. Okay. Problem number 8 can be a little bit tricky here if we are forgetting how to do our order of operations in reverse. So please remember, for these problems, we are doing that SAD method. So we are undoing addition and subtraction first, then undoing multiplication and division. Because of that, my first step on here needs to be getting rid of this 7. The reason for that is I cannot get rid of the negative 5 yet, because that is trying to multiply the inside of my absolute value. I can't undo multiplication until my second step here, so first I have to get rid of this positive 7. I do that by applying the opposite to both sides, which is a negative or minus 7. That cancels out here, leaving me with negative 5 times the absolute value of negative 2x minus 2 is equal to negative 18, negative 7 make negative 25. So now I have negative 5, absolute value of negative 2x minus 2 is equal to negative 25. Again, a lot of times when students get here and they have a negative on the other side of their absolute value, they are thinking it is a no solution problem. That is not the case here because I still have to get rid of the negative 5 before I can say that. So to get rid of the negative 5, since it's attempting to multiply, we cancel it out by undoing that, or dividing on both sides by negative 5. That cancels out here, and negative 25 divided by negative 5 is going to give you a positive 5. So we have the absolute value of negative 2x minus 2 is equal to positive 5. We drop our absolute value bars and split the problem into 2. So again, on the left side, I'm going to do my positive version. Negative 2x minus 2 equals positive 5. On the right side, I'm going to do my negative version. So that's going to be negative 2x minus 2 equals negative 5. Again, though, it is going to be the same 2 steps to solve both problems. We always add or subtract first, so we get rid of the minus 2 first. So when we simplify that, it cancels out the minus 2. On the left side, we are left with negative 2x is equal to positive 7. On the right side, we are left with negative 2x equals negative 3. Because remember, a negative plus a positive we treat like subtraction and take the sign of our bigger number. Right, at the end here, we need to divide both sides. So I divide by negative 2 to finish isolating x. 7 divided by negative 2 is going to be negative 7 over 2, because a positive divided by a negative gives you a negative answer. So x equals negative 7 over 2. We do the same step on our right side, divide both sides by negative 2. A negative divided by a negative is a positive, so that's going to give you positive 3 over 2. Again, we get 2 fractions for our answers. This is something we need to be comfortable with. Please also make sure that you are watching your signs when you go through here. It is really, really easy to forget that 2 negatives when we have a fraction should turn that entire fraction into a positive. Same thing here. We had 1 positive number, 1 negative number. Please make sure your answer is negative as well. All right. So please make sure you guys are studying for the test, getting that 1-pager finished up. With any time left in class today after you are finished correcting your test and writing down all the correct solutions, you should be working on that 1-pager and then completing any missing assignments you have. Good luck, everyone.